Hello, my name is Sarah Rutledge, and I'd like to present today on some water bottle flipping data that my husband and I found. So, he's a math teacher, and his students are really interested in seeing if they can mimic the YouTube sensation of flipping a water bottle and having it land upright. So he found another math teacher that actually did this with some students, and they experimented and saw how often they could make the water bottle land upright. And they tested it at different levels of fullness, how full they filled the water bottle. So they plotted their data, and that's the data I'd like to share today.
Here is the blog where I found this information. This is the graph here at the bottom. They state that they used 32 bottles filled to varying levels with water. In a 20-minute class period, 32 students flipped those bottles 4,220 times, and they put that data into a spreadsheet and created this graph with it. If you look at this graph, which you can also find here through their link, you can see that with no water in it, that it does not stand up at all. There's very little to no success getting it to stay upright. As you move toward 30% full, it goes up and it peaks at about 33% full, which you can see on the left side over here has a point of 32.3% with a 39% success rate. And then as you continue to fill the bottle more than that, the success rate, how often it will land upright, goes down dramatically, all the way down to 1% as you get it to all the way full. So there's obviously an optimal point to fill it to that you don't want to go below, but you don't really want to go over. And there's a little bit of margin of error that, you could be pretty safe in, but not too much. This information doesn't have any great and eternal significance for anything. You could use it to impress your friends with your knowledge and or to optimize your chances of being able to successfully land the water bottle as you try and perform this trick in front of them. You could use it to kind of engineer and practice principles of engineering and physics and see how this all works and what it means. You could practice statistics tests on this and see if there's anything significant, but it's mostly just ridiculous fun. It's pretty credible information. These students and their teacher did this together, and they aren't out to lie about it. What good would that do them? And they do have a really large sample size, but we're not exactly sure, based on what they gave us, how well they controlled their other variables, so there's some room for error in there. I wish that they had taken some more time to consider some of the different things that could affect the water bottle success, such as the shape of the bottle, its height versus its width, the weight of the water versus the percentage of the volume, which would be correlated but not necessarily the same. I'm pretty sure that this has probably got something to do with the weight to height ratio, so that might be something to consider. The other thing is, how high are they flipping these bottles, the angle, the speed, direction that they flip them, as well as the surface that it lands on. I would imagine that different surfaces, carpet and tile and tables and cement, all would have a slightly different effect on the bottle and whether it would bounce or stick. So it would be interesting to know what they did it on and if they would test different surfaces. But those are my considerations and how I see this data. So if you want to flip a water bottle, fill it to about a third of the way full, according to this data, and you should succeed a little less than half the time. So hopefully that at least brings a little bit of amusement into your life today. Thanks.